Morning.
Morning.
Vending machine.
This
I'm gonna tell the school.
This is fourth period. Today is the 24th, 2019. I'm actually giving you the date today. Shocker of shockers.
Sarah.
That means it's gonna be like
Right, and giving your period credits. Whoop, whoop. This way you can see how long it takes me to actually post. You're like, Miss, that posted on the 27th, but you did it on the 24th. What's wrong with me? Sorry, got
32 is
distracted.
the first one.
All right, so you're saying it's 32, but how did you get there?
My man.
How?
I multiplied 2 times 2 times 2 times 2 times 2. I think I missed a 2.
That's okay. He did that in his brain. It's perfect. It's exactly what the exponent means. Okay, don't give me the number on the next one. Give me the process. What would be the process? Negative 3, 4 times. So negative 3 times negative 3 times negative 3 times negative 3. With the fraction, what would be the process?
It would be
And that's what I heard you all mumbling.
Mm-hmm.
Look at the last one.
Negative
be negative 5 times.
Okay, so I heard negative 5 times negative 5 times negative 5. You have a different opinion? Okay, that's all right. We like difference of opinions in here.
For the negative?
There's a difference between these two, though, isn't there?
Sounds parentheses.
This one has parentheses, so we had to include the negative when we did that repetitive multiplication. This one does not have the parentheses, so I cannot include the negative in my repeated multiplication.
Wait, is it negative 5 times 5 times 5?
It's negative times 5 times 5 times 5 times 5.
Hanging on my face.
Is that what you were thinking your difference of
I
opinion
got
was?
so confused.
Next time have it. Okay?
Basically, when it doesn't have a parentheses, you only add the negative once, and it's not with the 5.
Correct.
by itself.
It's kind of chilling, and then it gets tacked onto the
Chilling
end.
on its solo.
Yeah, all so low. YOLO, poor thing. Okay. These are all examples of the exponential function that we had. We took a number, we raised it to a bunch of different powers, which meant we multiplied it to itself a whole bunch of times. And there was some refraction thingy happening when that number of times was a negative, right? Part of what we did last unit was to find the inverse of this thing, where we ended up with like a vertical asymptote and stuff, right? And it started to grow, but really slowly. Yeah, remember that graph? A little bit, we did just a little bit. The name of that inverse is the logarithm. So we're going to be doing the logarithmic functions. B is still called the base in this particular section. Okay, so it's still the base. Let's look at how we write logarithms and how we read them. So this is read log base 10 of 100 is 2. Oh my goodness. That's my phone.
Your phone's over there.
It's over there. Yeah, go and just. You are more important than they are.
So loud.
Sorry, it's because it's connected to my Bluetooth. I'm so sorry about that. My apologies.
I thought someone was playing my report.
I'm so sorry. I'm sorry. Let me reread. Let me reread. Log base 10 of 100 is 2. Okay? We're going to read this one again. Log
Base of
base 7
of 343 is
of
3.
343 is 3. All right, let's practice translating these into English.
So you're
Log
pretty
base
much
5 of
just, like,
125 is 3.
making what that is into like a sentence.
Yes.
125 is 3.
That's simple.
That's simple. Okay? Congratulations, you're translating math into English.
Log
I have
base
finished
2 of
sixth
32 is 5.
Bark, base.
All right? Easy enough?
Yeah.
Easy enough? Now remember we had chatted briefly, right at the start of this, that logarithms and exponents were related? They're inverses of each other?
Yeah.
This means I can go back and forth from one to the other. This is how. I'm going to rewrite logarithms. Okay? Here's log. Here's the base. There's the base and the exponent. Here's the exponent in exponential form.
So it would be like,
Here's the exponent of that in the log form. Here's
like 10 to the power of 2 equals 100.
Here is the result after you apply the exponent to the base. In logarithmic form, that result is found here. Okay? So let's rewrite this log base 10 of 100 is 2 as base to some exponent is some results. All right. Base to some exponent is some results. All right. What was the base?
10.
What's the exponent?
2.
2.
What's the result?
100.
That's it.
Oh.
I had 2.
Okay, I get it now.
That's it. Don't overthink it. That's it.
I'm confused.
Stop overthinking. You're confused. Tell me where. Ask me your question.
It's easy.
Wait. Shh.
Why is the 2? the
Because
exponent?
10 times 10 is 100. So 10
Right,
to the
'cause-
power of 2 is 100.
Oh, okay.
Yeah.
Okay.
Yeah.
All right. We're going to rewrite this one. What's the base? What's the exponent? What's the result?
343.
Perfect. You could go the other way around.
Log,
From exponential form to log form.
log 5.
So can it be log
equals X.
5 and then x, wait no, 125 equals x.
125 equals X.
Oh, party, I got it.
You say party?
Yeah.
Here's
That's 'cause I
the
wasn't even paying
base.
attention, that's like the first one I got.
There's the base. Here's the exponent.
That's it.
Exponent is
Here's
always
the
the one that's
exponent.
equal. That, oh, okay.
Here's the result. Here's the result. Boom. Okay, I'm pausing here.
So like the little number is
The base.
the base,
Yes.
and then okay. And then the x will be the exponent.
Yeah.
So it's literally the same for this.
Okay, that makes sense.
Yep.
Makes perfect sense.
Good. Great. All right, so we're going to practice rewriting. We have 3 practices to do. I'm going to start on the right side of the paper and work my way left. Okay? So I'm going to start here, and then I'm going to go that way. All right. I don't have an equals to. So our first step to rewriting is to make sure we have an equals to. And if I don't know what it equals to, I'm always going to put x. What's the base?
2.
2.
2,
What's the exponent?
4,
4.
No.
Wait, no.
X.
It's X.
What's
Equals
the
4.
result?
4.
Equals 4.
I could, if I wanted to, figure out what exponent I have to raise the number 2 to in order to equal 4, but that's not what I was asked. I was asked just rewrite the thing. Did I rewrite the thing?
Yep.
Yes, I'm done. Okay? I don't care what x is right now. I'm just rewriting. All right, let's look at the next one. What's the base? This is an
Base-
exponential
the Base
form.
is 9.
The base is 9 because that's the thing that's holding the exponent.
Log
Base
9
is
of
9.
1 over 81
The result is 1 over 81.
equals negative.
And the exponent was negative 2. Okay? For my football fans, are you ready? Let me show you how to do this as like a football play. Ready? This player goes here. This player goes here, and this guy runs all the way around over there.
Hold up, man. Let me.
Isn't that Daniel? Isn't that Bobo or something? The one in the
What?
middle goes like
There
that.
it is, dude.
Look, this is getting recorded. No, don't tell everyone what our play is.
Okay.
Dude.
Actually, but that's called film, and it's pretty much every team watches.
Oh, okay, then.
Blockers.
All right.
Yeah.
Yeah, so the 2 blockers come this way, and that guy runs around to go try to grab the ball.
Ernie Shark's kicking it with his foot.
Do it
And it
like-
makes a mess. If you're not into football, don't worry about this, okay? Just hopefully the arrows. Yes? Okay. Let's practice rewriting this one. I don't have an equals, so I need to put it. Equals x. What's the base?
3
Exponent?
x equals 130.
What the heck?
That's it!
Is that it?
That's it for the rewriting. That's all you got to do. I know, right? We can use this rewriting thing to help us figure out what values x has to be. All right? So let's play with this one to try to figure out what value x has to be. Rewrite it first. Base,
2.
exponent,
X equals 64.
what power of 2 gives you 64?
Oh,
How many times do I have to multiply 2 to itself
Four.
to give me
18.
64?
No, not
Four.
18.
8, 6,
1
4.
million.
I got it.
Okay, do it. Go 2 times 2 times 2 times however many times. I'm getting 6.
Yes, it is 6
Six.
because 5 is
Six.
32. 32 times. Yes.
I didn't even say that.
I don't know. I got 64, but I don't know how I did
I
it.
didn't even say that.
Did you do 2
I
times
got
2
it.
times 2? And then you
Yeah,
just
it's
need to
six.
count how many times you did that, yeah.
Just like
All right, this one.
6x equals 36.
All right, pause. He said 6x equals 36.
So
6 to the power.
Thank you. Otherwise, it sounds like you mean 6 times x. And I'm being told that x is 2?
Yes,
Yes,
ma'am,
ma'am.
it is.
All
I
right.
have done a calculation.
Don't you wish that for some of these there was a shortcut?
Yeah.
What do you mean?
Because right now you have to write this first. Okay? And on some cases, writing that is kind of like you don't need to do it. Because I have some properties. These are your shortcuts. Your
Where?
properties can go on your 3x5 index cards. The formula to rewrite, the recipe to rewrite your logarithms can go on your 3x5 index cards. Okay? All right. Let's go over the properties so that we have some shortcuts so as we continue working through our examples.
Bye.
We can look for shortcuts and like just write answers, okay? Here's the first shortcut. First shortcut says log some base of 1 is 0. So if I see log with some base, I don't care what the number is, just some base, of 1, my answer is going to be 0.
And if it was like 2,585, the base.
Anything base,
No matter what.
log of 1, no matter what.
Even if it was infinity.
Even, well, okay. Make it a number, okay, please.
What about like a million? Will it still be
Sure.
0?
Log of base million of 1, 0. Log base negative 40 of 1, 0.
Pi.
Well, maybe not negative, right?
What about pi?
Yeah, log base pi of 1, 0.
So anything with the
Anything but
Any
negatives
log
and infinity.
base
So
to
no
1
matter what, like
is 0.
no exception.
Here's why. Let's give you the reason so that you know there's no exceptions.
I'm just saying.
We're going to rewrite this. What's the base? B because I don't know.
Yeah.
B for base. What's the exponent?
0.
Oh, okay.
Anything that the 0 power is?
0. Was I here?
No.
Yeah?
Was I really?
All right.
Maybe, I don't know.
Oh.
Here's your next shortcut. Do you see the matchy-matchy? Look, I have matchy-matchy. Matchy-matchy and no power on the second match. Log base B of B is 1.
So the base and
No
the
matter what.
It's the same power.
If the base and the result are matching, your power is 1. Here's the reason. What's the base?
B.
B,
What's the power?
B,
B.
no, 1, 1.
1.
1.
1.
Anything to the first power is?
Itself.
Itself.
Oh. So anything
Anything to the first power is itself. Log base matching
Yeah.
here is
It looks
0,
like
is
a
1.
smart language, but we're retarded. We only speak retarded. That's smart language.
Wait, your last shortcut. Gonna blow your minds with this one. Log
I read that.
base b of b to some power is that power.
B to the power of x equals b to the power of x.
Okay.
Okay? What's the base?
B.
Okay, I'm gonna highlight and put my colors back so you can see where things are coming from. Okay, there's the base. What's the exponent?
X.
What's the result?
Bx.
Oh,
Hold on.
B to the power of
Am I
x.
dumb?
Or is it? That's how you say it.
b to the power of x.
That confused me, miss.
but
To
it's
be
so
honest.
simple. Basically,
Is it
it's
just
basically
equals the
right
same?
here.
It's the whatever's there.
Highlight this.
Real quick.
Put a triangle around.
Can I just do my?
Yeah, if you're happy with this, go for it. But shh, don't interrupt what we're doing over here because some people are not quite as. It's okay. I see thinking faces on this. I'm just gonna wait. Ask a question if you have one.
Can we apply those
Is it
to some of these samples
Yes.
to understand?
Wait, so no matter what the number is, it's just like the same.
As long as I have matching here.
So it's like the base is
I'm
1
gonna-
and then
Yeah, hang on. Hang on. Shh, shh, shh. So if these two are matching, then my result is this exponent
Why?
because of this.
Okay, hold on. Let me process that.
Process that.
Processing bar loading.
Shh.
Forever.
Let it process. Yeah? All right. I got the thumbs up. I have to say that for the recording, otherwise people are thinking that I'm just talking over your thinking. It's like, what? Why is she going on? Yes? All right.
Did you have a loading error?
Let's practice some of these on our examples at the bottom. Okay? All right.
Do we
I'm going
have
to
to
poke
use
at this
shortcuts
one.
all the time?
If you can use the shortcut, use the shortcut. If you can't use the shortcut, then don't.
That's one. Those ones.
All right. Look at this.
the matching.
It's
They're
one.
matching. I have no power,
You can apply one of the
which means the result is
one.
What I see.
Okay, so if they're matching, it's 1.
So we just write
if they're
one?
matching and no power.
And no power. Okay.
But if I look at this one,
Oh, okay.
matching,
Matching.
but with a power.
Power.
Wait, which
So
one's
it's gonna be
matching?
like the
It's gonna
It's
be
the power.
Oh,
That's the answer.
Wait, so wait.
Let's talk about why on this one, because this is the one that feels weird, okay? All right.
Oh, I got it.
Shh, shh. I'm going to set this equal to x.
Can I guess?
Wait,
No.
wait,
Wait, let him
wait.
talk.
I think you know too, but wait.
I think I don't.
Wait. Shh, 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 shh. Set it equal to x, okay? We're okay with that so far?
Yes.
What's the base?
79.
What's the exponent?
3.
Three.
X,
No,
X,
X.
X.
What's the result?
79.
79 to the power of 3. So
I
x
have-
equals 3.
I have 79 to some power equals 79 to the third power.
So if they're matching,
Miss.
It's just filling, it's kind of like filling the blank.
Fine.
Exactly what I
Fine.
Listen to this.
Okay.
Listen to this.
What if it was, I saw it like this, because you know how the B equals B, right?
Yeah?
So the 79, 79 are the same.
Yep.
Which equals 1.
Yeah.
1 times 3 is 3.
Hang on.
It's not
Wait,
always
wait, 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 wait. I gotta think through what he said.
She has to process.
I do.
Yeah.
There's an argument to be made for it, and it's because of that matching. So if you want
They
to,
both match, it equals 1.
with division, right? You're thinking through division. 79 divided by 79.
No, because like how on the properties, how log, the underbeat, and the millies, right? You input the 79s, just take the exponent to the side,
Okay.
and then you times the 1 to the
Okay, I see what you're doing there.
So here, you just got a message
For
from-
this case, I'm okay with that own little mental thing. I'm hesitant to teach it that way just because it could cause errors later. But your internal thinking on that is I don't think it's going to cause any issue. So go for it. Okay, good. Let's do this one.
So that, I think that one's 250.
Okay, he's thinking this one's 250.
Cause like, see, cause log base, 1 on top.
It's 250,
Shit,
because
I don't know. I had an answer, I had it in my mind, but I lost it.
All right, let's look at the properties. So I have log with some base of 1.
anything, the first power equals itself.
You're not wrong, but what we have is log to some base of 1.
0.
I had a point, but I forgot it.
Wait,
So it's 0.
It's 0.
Okay.
Okay, I have a thinking face, so I'm going to come back down to here and let's write it out the long way. This equals x.
250 to
'Cause I don't know.
x equals what?
250 to some power equals 1.
anything that equals to 1 is 0.
What power do I have to raise some number to give me a 1?
0.
1.
The 0 power, because that one's weird. Okay. You were overthinking it.
It's too simple. That
Log some base of 1, 0.
It's because it's too simple to make one.
It's too simple. You want it to be hard because
Yeah, it needs to.
you should be hard. No, to let it be simple, sweetie. Let it be simple. I want to poke at this one.
I feel like I'm gonna agree with you, man.
Honestly, me
Hi
too.
guys. I want to poke at this one next because it's got a fraction and I know you guys are like, ah! Okay, equals x. What's my base?
7
What's my exponent?
x
What's my results?
1 over 342, 343.
All right, so I have a whole number base
I knew I had it.
and a fraction result. To make that happen, my exponent had to have been negative. Okay? Because when we were evaluating exponents last unit, I said anytime you have a negative exponent, you flip the base, right? So I'm going to trade this out for this. I have a negative exponent now. So now I'm thinking, I'm going to set the negative off to the side for a little bit. So here he is, just hanging out and chilling, waiting for an answer. I want to know, what do I raise 7 to give me 343?
Hmm.
Okay, so do 7 times 7 times 7 times 7 times 7 times 7.
Because 7 times 7 is 49.
Okay, 7 times 7 is 49. I'm going to scribble it over here.
49 times 7.
3, it's 3.
Yeah, so it's 3.
It's 3. Okay.
Yeet.
This is right there. Okay? The last one I want to poke at is this one. Again, because I have another fraction with the x. What's the base?
64
64.
Exponent?
x
Results?
equals 144.
Then you switch it out for.
Wait. I love how you already went there. Yes, we're probably going to do a switchy out thing for a negative. Okay? But I want you to notice something. In this example, we went from a small base to a large result. And here we're doing a large base to a small result. It is going to be negative because this is still a fraction. Okay? So we are going to end up with a negative. The problem is that exponents tell you how many times to multiply something together. And if I were to take 64 and multiply it by any whole number, I'm never going to get to 4. It's going to end up being bigger. Here, I took 7 and I was counting how many times I multiplied 7 together. Yes? My counting numbers are, whole numbers, 1, 2, 3, 4, 5, 6, 7, right?
Yes.
So I did 7 to itself, stay with me, 7 to itself 3 times, and it gave me a very big number. If I took 64 and I counted how many times I multiplied 64 to itself, I would never find this counting number that gave me 4. So instead of thinking about multiplication, I'm going to think division. How many times do I divide 64 by 4 to get to 1? All right, so we're going to do 64 divided by 4. This is my first division. What is this result? 64 divided by 4? 16 from the back. 16 divided by 4.
4.
4. 4 divided by 4.
1.
1, I've gotten to my stopping point. I divided 3 times. Okay? But exponents don't talk division. Exponents tell me the number of times I'm multiplying. Okay? But if I'm going to switch back and forth between multiply and divide, multiplying by 1/2 is exactly the same as dividing by 2.
1/3.
Divide by 2 is the same as multiply by 1/2. So multiply by 1/2 is the same as divide by 2, yes? I divided by 4. Well, if I want to write it as multiplication, because this is an exponent, divide by 4 is the same thing as multiply by
1/2.
Chill. So if it was 3.
This is why I got confused on the
Oh, wait,
Isn't it?
no, yes, you're right. I'm sorry. I'm grabbing this number. That's the one that goes here.
3 goes in there.
Yes.
Yes.
Because it's counting the number of times you're doing the thing.
Okay, so let's say
My apologies, you're right.
Let's say you do it like
I was confused.
you times it like 4 times. In that case, it would be 1/4.
Then it would be 1/4.
And so like if it was like 6, it would be 1/6.
Yes.
Whatever that is, it'll be like that.
Yes. Okay, so I'm going to come up here and grab this example because we've already done this one. Okay, so I'm going to do log base 32 of 2 equals something. Okay?
32.
Oh, needs to be a 5.
32. 32.
Needs to be a 5 or needs to be a 2? Hang on.
32.
No, it needs to be 2. Okay. So, I'm going to try to figure out what I need to how many times I need to multiply 32 by itself in order to get to 2. How many times do I need to divide 32 by 2 in order to get to 1? Okay? So 32 divided by 2 once, 16. 16 divided by 2, 8. 8 divided by 2, 4 divided by 2, 2 divided by 2. I'm at my stopping point. I did 5 divisions.
So 1/5. So 1/5.
Yes. Because this number is counting how many times you're doing the thing.
So we wouldn't have to multiply by.
We're not multiplying when this result is smaller than the base.
So you have to divide it to get to 1?
To get to 1. Because if I kept dividing, I would start getting fractions, and I don't want fractions. I'm dealing with enough fractions already. In this case, no, because my result is a positive, is a whole number. Great question. If my result was a fraction, then yes, it would be. That's it. That's all I had.